Next, we will discuss about the actuation of direction control valve. That means how we are going to actuate the various position of the direction control valve. This actuation can be done with the help of four basic methods that may be done with the help of manual, mechanical, or solenoid operated, or sometimes it may be a pallet operated or the pallet pressure operated. And even I can go for the combination of these things also. In case of manually actuated, in case of a manual actuated, we'll be using either the push button or stepping up of the foot pedal or even a hand lever. Right? So these are the symbolical representation of such type of push button or a mechanical lever. Right? So by actuating, in order to actuate the first position of this direction control valve, 4 by 2 direction control valve, I need to operate this lever. Right? So even here also the roller tappet we are having. So by operating this roller tappet, I will be actuating the first position. If you won't actuate this position, then obviously it will go to the spring return position, which is nothing but the second position. Right? So this is in the case of the manual actuation. Right? So some more also we can discuss here the symbolical representation which will be using for general manual actuation is this one, and for push button is this one, and for lever actuation as well as for detent lever actuations, these two we are using. This is in the case of the manual actuation of direction control. In case of mechanical actuation, we are using the cams, the plunger as well as the rollers. Right? So such type of equipments or the components will be using in order to actuate the various positions. Right? So along with that one, these are few more actuations also considered under a mechanical actuation, such as the foot pedal, the roller, the idle return roller actuation, as well as the usual spring return actuation also we are considering under the mechanical actuation. The next type of actuation is the solenoid actuation. In case of solenoids, the solenoids are mainly used in order to change the position of the spool as well as spool land. Right? So that can be done by energizing the coils as well as de-energizing the coil. Right? So assume the first diagram is for the de-energizer condition. In case of de-energizer condition, I will be having the spring force which will be more compared to the coil force. Right? The coil is in the deactuated position. Right? So here the flow will be taking place from 1 to 2 as well as from 4 to 5. But when you supply the electric voltage here, the coils will generate the electromagnetic force, because of which the coil will be the coil is going to attract the conducting material whatever we are connecting to this spool, so that I will get the left side moment of this spool against the spring force. In that case, the one port will be connected to 4 port as well as 2 port will be connected to 3 port. Right? So this is how we are going to control the position of the spool as well as the spool land with the help of the energizing as well as de-energizing the coils. Right? So the symbolical representation what we are using for a single sided solenoid is this one, and for double solenoid is this one, double sided solenoid. Right? And next, even I can go for actuating a position of a direction control valve with the help of pilot signal also. The pilot signal may be a hydraulic pilot signal or that may be a pneumatic pilot signal. Right? So in case of hydraulic actuation of the hydraulic pilot signal, we will be using the hydraulic pressure in order to actuate the position, right? So assume in this diagram what we are having. So it will be initially the piston, this piston will be having this position, and the spool is going to close the port, this port. When you apply the pressure here, when you apply the pilot signal, the pilot signal is nothing but the another hydraulic force or hydraulic oil pressure which is going to act on this smaller piston, so that the piston along with this, sorry, the spool along with the spool end will be moved towards the right side, so that I'll be having enough space to move the hydraulic fluid from this port to this port, right? So unless until you operate the pilot signal or the hydraulic pressure here with the help of this port, there will not be any movement of this spool that will be taking place. And this needle valve we are using in order to control how much amount of the fluid that will be circulated from this channel, right? So how fast you are going to actuate this type of pilot signal that can be controlled with the help of that needle valve, right? So this is the symbolical representation of the hydraulic actuation, because the triangle is completely filled here, right? If it would have empty, then I would have called it as a pneumatic actuation, right? So this is for the pneumatic actuation, as I said. So here we will be supplying the pneumatic air or the compressed air. By supplying the compressed air, we will be actuating the parallel connection of the hydraulic flow. And if you want to actuate the second position, then you need to apply the the pneumatic air pressure to the Y section, right? So the Y passage. This is in the case of pneumatic actuation. And the last one is the combination of the hydraulic as well as the electric one, right? So this is the main or the larger direction control valve, and this is the solenoid actuated or the smaller valve, right? So in order to actuate the main direction control valve, I will be using the another direction control valve, right? So this is the 4 by 3 direction control valve, which is of closed center, because in the center position all the ports are in a blocked condition, and this is of floating center because the A, B as well as T are connected and pump port is completely blocked, right? So I will be actuating the smaller direction control valve with the help of solenoid here. With the help of solenoid, I will be actuating the smaller direction control valve, whereas I will be actuating the main or the larger direction control valve with the help of the hydraulic oil or the hydraulic pressure here, right? So once in order to actuate the first position of smaller direction control valve, I should give the electric voltage in order to actuate this solenoid. Once this position is actuated, then obviously the flow will be taking place from this end to this end, right? So that this position will be actuated. This position of the main direction control valve is actuated. Similarly, when you actuate the right envelope of a smaller direction control valve, then obviously the hydraulic pressure will be acting on the right envelope of this main direction control valve, so that I'll be connecting pump to B and A to T, right? So this is nothing but indirectly we are actuating the main direction control valve with the help of the another direction control valve, which is operated with the help of electrical signals, right? So this is the graphical symbol of the indirect actuation of direction control valve, right? If I, along with this filled triangle, if I show a cross line here, this is called for the indirect actuation of direction control valve. Right. Thank you. Thank you for watching.